Hi guys, welcome back. Now we are going to see example 23 that is discussed in your matrix lesson that comes under elementary transformation of a matrix. Now we'll see by using elementary operations find the inverse of the matrix 1 2 2 minus 1 is your question. Now this question is looked upon by a textbook in two ways, that is method 1 and method 2. Now we will see how these both methods generally work, right? Now we will see the first method by using this find the inverse of the matrix. Okay, fine, let this matrix be A, right? Let the matrix be A. Now first, this A equal to I A is your first important step that we need to discuss, or that we need to write when you are going to solve this elementary operation, right? Using this elementary operation find the inverse means your first and foremost step is A equal to IA, right? So A value holds 1 2 minus 1 and 2, that is equal to 1 0 1 0 into A. Now your first step begins. Now change. Here our ultimate aim is to find the value of A inverse, right? How can this A inverse can be achieved? How you know our A inverse is achieved? When you get 1 0 0 1, this value in the left side, the right side value holds the A inverse value, right? By solving the step you will get it. The first step can be done here is R2 to be R2 minus 2R1. So you're going to touch with R2. So just write R1 value as it is. R2 to be R2 minus 2 R1. R2, that is 2 minus 2 times 1 is 2 again, so 0. Similarly, minus 1 minus 3 is, minus 1 minus 4 is minus 5. So 0 minus 2 times 1 is 2, thus 0 minus 2 is minus 2. This comes as 1. So this is your first step in order to achieve our destiny, right? So we'll see the next method or the next step to continue our transformation process. Now, as I told you, the left side we need to get identity matrix, that is 1 0, the unit matrix 1 0 0 1. So R2 is minus 1 by 5 times of R2 in order to make this value to be 1, right? So this changes to 1 0 1 2. R1 should be left undisturbed. 1 0. This becomes as minus 1 by 5 and this becomes as 2 by 5. Just don't bother about what your right side value is getting about, right? Ultimate aim of this elementary transformation is you need to make this left side to be 1 0 0 1, and the respective right side value will holds the value of A inverse is what your ultimate aim, right, of elementary transformation. Just focus on the left side. Our left side aim is to we need to get 1 0 0 1, that is the identity matrix, right? So 1 0 1, our aim now is to change this 2 to be 0. What can be done? Merely just write R1 to be R1 minus 2 R2. Have a look upon it. Now here we are just changing the value of R1, so R2 remains undisturbed, same both right side and as well as left side, right? So 2 by 5 minus 1 by 5, both the values remains left undisturbed. Now R2 R1 minus 2 R2, when you change this you get the value 1 0 0 1, and this value to be 1 by 5 2 by 5, right? So A inverse is the value 1 by 5 2 by 5 2 by 5, this value minus 1 by 5, this value will be your A inverse. Only when you get this identity matrix in your left side, the right side value holds A inverse. Till you get 1 0 0 1, you need to repeat as much as repetition that is coming in any other form, right? This is not necessary that R2 should be do R2 minus 2 R1. It's not fixed. It depends upon the matrix that is given in your question. So this is one method. There is alternate method to find this A inverse, which is much simpler. Again, I repeat, this simpler depends upon the given matrix that is in the question 1 to 2 minus 1, right? It depends upon the given matrices. Here, this is much simpler when you try this alternate method. This is your method 1 and this is your method 2. let it be like that. In method 1 we focused on row, right? In method 1, I repeat, in method 1 we focused on row wise transformation. In method 2 we are going to focus on column wise transformation. As we seen in the previous video, this elementary transformation is merely depend upon changing the rows or columns. Now by method 1 we changed every rows in order to reach our destiny, that is A inverse. Now this alternate method we are going to change every column, whether it may be in number of steps. We just don't need to bother about the steps, but this is just an alternate method. Here we are going to change columns in order to achieve our A inverse, the same result with changing the column. Now we will see what is the first step. Again, A equal to IA, therefore 1 2 minus 1 2 equal to 0 1 0. A, focus on column, so C2 is changed as C2 minus 2 C1. Instead of here the same process, instead of R2 C2, R1 C1, right? When you change like this, what will be your result, right? The same, instead of R2 C2, instead of R1 C1, right? What will be your result, right? Change the C2, so C1 remains same. So this is the most important point, C1 remains same. When you change this, 2 minus again 2, right? This one is here, this 2 is here, 2 minus 2 2s are 1, so I'm sorry, 2 1s are 2, 2 minus 2 is 0. Similarly you get it here has to be minus 5, here minus 2 1. This is your first step when you apply C2 minus 2 C1. Similarly the same process, C2 to be changed as here minus 1 by 5 R2, here minus 1 by 5 C2, right? What do you get? Again don't disturb the column 1 because here fully we are focusing on column 2. 1 2 remains same and 1 0 remains same. Minus 1 by 5 C2 0, minus 5 by 5 you get it as minus 1, and again minus 1 is present here, so 1, right? This holds 2 by 5 and this comes as minus 1 by 5, right? As per the technique which we have used, that is C2, that is minus 1 by 5 C2 changes to be minus 1 by 5 C2, so you get this. Now again R1 gives us R1 minus 2 R2, same, C1 changes as C1 minus 2 C2, right? So again just see the C1 value alone, don't disturb. C2, you get it as this 1, yes, C1 should not be disturbed, right? So 0 1 remains same. Similarly this 2 by 5 and minus 1 by 5 remains same. Okay, what will come as C1? C1 is C1 minus 2 C2, so 1 minus 2 times C2, this is column, right? 1 minus 2 times 0 is 0, so 1 minus 0 is 1, so here 1. Similarly 2 minus 2 times 1 is 2, so you get it as 0. Similarly in the right side this is column, just don't get confused, now we are in the column side. So 1 minus 2 times respective of this is 2 by 5, so 1 minus 2 times 2 by 5, right? Then yes, you get it as 1 by 5. Similarly when you apply here, 0 minus 2 times of minus 1 by 5, 0 minus 2 times of minus 1 by 5, so what do you get? The result has to be 2 by 5. Therefore as I told you before, you need to get the identity matrix at the left side, which we got here, right? 1 0 0 1. So it means the right side will be your inverse matrix of the given question. So that's your conclusion. So 1 by 5, 2 by 5, 2 by 5, minus 1 by 5. That's the same answer which we got in the first method, that is over here, right? You get A inverse equal to 1 by 5, 2 by 5, 2 by 5 minus 1 by 5. The same value you got here also when you try differently. That is, here we did with row wise and here we are doing with column wise, right? That's the difference, but you got the same result with the same number of steps, 1, 2, 3 and your fourth step is your answer. Similarly, step 1, step 2, step 3 and the fourth step is your answer. So this is your elementary operation example 23 that is discussed in your textbook. The next video will see example 24 and upcoming questions that is present in your textbook, right? Thank you guys, and do subscribe my channel for more upcoming videos and share it to your friends, which will be very helpful for them to clear these subjects, right? Thank you.